There are some situations where solving for x might require more than one step. So in this video, we're talking about two-step equations, and you're going to see in a minute why I would refer to these as two-step equations when it's time to solve for the side length. So again, we have a triangle. It's a right triangle. We know we're using sine, cosine, or tangent here. So now it's time for us to identify which sides we will be using here. So it looks like we're using the opposite side of this 34-degree angle, and we are also using the hypotenuse of this 34-degree triangle, of this right triangle with a 34-degree angle in it. Okay, so again, I'm going to ask a computer or a calculator to compare those two sides for me, and the way that I'm going to do that is I'm going to say, what is sine of 34? So when I do that, the calculator is going to compare the opposite side of a right triangle to the hypotenuse side. Okay, and I don't need to write what the actual value is in this case, but now what I'm going to do is write the other side of this equation. I know that my opposite side is 15 and my hypotenuse side is the x. So this is where we're in a situation where it's going to take two steps to solve this. It's not like the other examples where the x was in the numerator and the 15 was in the denominator, because this is a case where I'm going to have a hard time getting that x alone if I want to do it in one step. It would be a mistake to multiply both sides by 15 because that wouldn't cancel anything. That would just create a 15 squared in the numerator. So what I'm going to do is multiply both sides by x. And so now my equation says x times sine of 34 equals 15. And I don't have my answer yet. I still need to get x alone. So what I'm going to do now is divide both sides by everything that is not x. The relationship between the opposite and hypotenuse sides of a right triangle from the perspective of a 34-degree angle. And now I have x equals 15 divided by the relationship between the opposite and hypotenuse sides of a right triangle from the perspective of a 34-degree angle. So this is what I need to plug into the graphing calculator, and I'm making sure that I'm in degree mode. So it's 15 divided by sine of 34. So I've found out that x is approximately 26.824. And that makes sense in my head. I'm just keeping track and make sure this makes sense. The hypotenuse should be the longest side, so it should be much longer than this opposite side length. So I've got 26.824 there. Let's do some more examples involving these two-step equations. So you should pause the video now and try to solve these. I'm going to assume you've already done that, and we'll walk through the solution. They're all right triangles, so we know we can use sine, cosine, and tangent. So let's start solving. So our very first triangle is comparing the adjacent side of this triangle from the perspective of an 18-degree angle to the hypotenuse side of the triangle. All right, so we are comparing adjacent and hypotenuse, and I know of a function that does this. So if I want to compare the adjacent side to the hypotenuse, I usually use cosine. I always use cosine. So I'm going to ask the calculator to compare the adjacent and hypotenuse sides of a right triangle from the perspective of an 18-degree angle. And so when I do that, I'm going to set that equal to the situation that I actually have here, which is my actual adjacent side is 12 and my actual hypotenuse is unknown. That's the thing we're trying to find. So we're going to have to do this in two steps. I'm going to have to multiply both sides by x because that x is unfortunately in the denominator. And so my second step here is going to say x times cosine of the relationship between the adjacent and hypotenuse sides of a right triangle from the perspective of an 18-degree angle is equal to 12. And now I just have to divide both sides by cosine of 18, which is another way of saying that long thing that I don't want to keep repeating over and over again. Thank goodness we have a faster way to say it. So x is equal to 12 divided by cosine of 18, which represents that relationship. So now I'm just going to type this into my calculator, and 12 divided by cosine of 18 is approximately 12.6 0.18 if I round to the thousandths place. So that's the length of that side x. Let's move on to number 2. Number 2 is comparing the opposite side of my triangle to the adjacent side of my triangle from the perspective of a 71-degree angle. So which function do I know of that compares opposite sides to adjacent sides? That's the tangent function. So tangent of 71 is going to be equal to my actual opposite side divided by my actual adjacent side. This is going to be 2 steps because the unknown is in the denominator. So I'm going to get it out of the denominator by multiplying both sides by x. So x times the relationship between the opposite and adjacent sides of a right triangle from the perspective of a 71-degree angle is equal to 29. And now I'm going to divide both sides by that proportion. And when I put that into the calculator, I get approximately 9.986. All right, last one. This one's a little tricky, but we're going to have to think about what we know about triangles. So remember that all triangles have angles that add up to a sum of 180. So all the angles in a right triangle add up to 180 degrees. And what these little symbols mean, these markings, show that those 2 angles are congruent, meaning they have the same angular measure. So if these 2 angles have the same measure, and I know that that angle has a measure of 90 degrees, then what I'm saying is, out of the total 180 degrees that a triangle can have, 90 of them are taken up by that right angle, and then that 90 is split in half by these 2 angles, which are congruent. So if you split 90 into 2 parts, you get 45 and 45, 2 equal parts. So these angles are 45 degrees. All right, so let's, I guess, focus on this angle right here. We'll make that be our reference point. So from that angle, we have our opposite side, and we are looking for the hypotenuse side. So we're going to want to use a function that compares the opposite side of an angle to the hypotenuse of that angle. And that function is going to be sine. So sine of 45 is equal to our opposite side, which is 9.3, divided by our hypotenuse side, which is the unknown thing that we're trying to find. Multiply by x on both sides. So x times the proportion, or the relationship between my opposite and hypotenuse side from the perspective of a 45-degree angle, is equal to 9.3, and I'm going to divide by that value, whatever it is. So x is approximately, and I'll do 9.3 divided by sine of 45, and that is going to be approximately 13.152. All right, so that's the length of that hypotenuse. Be careful how you're rounding, right? If the worksheet you're doing or the homework problem you're working on says to round to the nearest tenths, then this answer obviously would be 13.12, right? Because I would have to round, or 0.2 rather, because I'd have to round correctly. So pay attention to your rounding. But this is about as difficult as a problem can get when you know an angle and you're looking for a side.